A very good morning, everyone, and a warm welcome to this webinar, Automating Sales Forecast and Stock Replenishment with AI. My name is Jesper Højlund, and I'm Head of Sales of Beterna in the Netherlands, Denmark, Sweden, and Norway. We all see it. It's been a part of our daily news for a long time. We experience it in our daily lives as well as in our business we work in. We are in times when unpredictable demands in our markets increase the pressure on our supply chain, and it has a tendency to blur our ability to see across multiple data points and sources. The limitation of human capabilities disables us from considering patterns and data points and engaging with external data sources, and that could be time-consuming and challenging. But there is a helping tool that can provide insight and give us a helping hand in foreseeing patterns in our supply chain and our demand. For this webinar, we have invited Milan Listis to introduce us to modern tools that help you to foresee your supply chain demands. Milan, it's a pleasure to have you here. Good morning.
Good morning, Jesper. Good morning, everyone. Thanks a lot for this nice intro and for handing over to me to deliver this content. So first of all, thanks everyone for joining. My name is Milan, as Jesper mentioned, and just in one sentence, I spent 6 to 7 years as head of our data and AI department in Adriatics region, and now my role is to lead the pre-sales again for the data and AI. So pre-sales activities on our group level. Nevertheless, just a few quick intro that I'd like you to have in mind. So please feel free to drop down questions you have in a Q&A section. If we don't manage to address them during the live for any reason, we'll absolutely do that as a follow-up. So don't worry about it. And of course, there's a recording being in place, which is going to be sent to you more or less automatically. So please feel free to reshare it with your colleagues or whatever is needed to boost the discussion within your organization. So moving on to the agenda today. So after a quick round of an intro for our data and AI team, we're going to discuss which problems are we solving with this solution. How did we come up to approach this solution? Second thing that we're going to discuss is how do we solve it, obviously, and we're going to discuss a bit about solution overview from module perspective and from end user perspective, because it's really important. And basically, two last bullets are more or less a project oriented, so to say, and that is we're going to discuss how to calculate business benefits. So we have a luck that maybe comparing to some other business software implementations, here we can really focus on calculating financial impacts and pure business benefits that this solution can get your organization. And the last question we're going to try to answer here is, how can you start this journey and what would be the first preferable steps? So just a quick round of intro for the team that I'm coming from. So I think that a lot of you or most of you know Beterna, or either as a whole or as a group, or the Nordics team. However, inside of that team, there are between 70 and 80 people who are focused on delivering data and AI projects. And we do basically everything from initial assessments, planning together with you, up to the execution and support, lifetime support activities. And inside of that group, there's a pretty dedicated group of 7 people who are engaged in delivering, I like to call them applied AI projects. Why applied? Because we do not engage into some kind of general consulting or introducing AI or machine learning as a technology. So what we did in the past few years, we found a couple of really focused use cases in various industries, and for now we stick to them. So the one that we're going to discuss mostly today is demand forecasting and supply chain planning, and then if we're not talking about pure retail organization, but extending it to a manufacturing organization, planning and manufacturing process optimization comes hand in hand with it. So we can take a look at this as let's say one solution, but just depending on an industry that we're discussing. Let's say slightly more next to it is a topic of IoT predictive maintenance. So eating and understanding sensor data from various manufacturing organizations and production plots, and trying to figure out how to keep the maintenance in a predictive manner. So let's say we can put all of these things in one hat called supply chain planning somehow. And on the other hand side, the second focused issue we have here is customer behavior modeling, and that's the topic which is basically in the core of any personalization project that you might have, right? So if we're talking about retail, then it's in a focus of a loyalty project, right? If we're talking about, I don't know, banks or insurances, it's a personalized offering. If we're talking about hospitality chains, it's some kind of a personalized offering in terms of, a recommended stay, next best offer, and things like that. So basically understanding the behavior of your customer, not just the demographic capabilities. So this is what this team is pretty focused on. And today you're going to see, the progress and the response from the market we have from the projects on the topic of demand forecasting and supply chain planning. So to set the base for this discussion, we're going to answer the question, which problems are we trying to solve? So what we have here on this map is really, let's say, generic approach from initial financial planning to, getting goods on stock, to replenishing goods from central warehouse, all to markdown execution. So, various challenges from perspective of managing inventory. And what we did here, we mapped this process. I used the example of, let's say that we're producing or selling a pink chair. So I just used this simple example to see, which challenges do we have from managing inventory perspective down the road. So in the beginning, obviously, financial planning, we're trying to answer a question, how much revenue do we want to get from our, let's say, selling this pink chair, right? And then after we have this top line plans, we obviously have to answer the question, how is our assortment going to look like? So which portion of this revenue should come up, to furniture, to chairs, and then the pink chair, so to say. And then inside of that, there's a SKU planning. So inside of the furniture part, right, we have to answer the question, how much portion of the sales should go to the chairs itself, to the pink chairs, to the blue chairs, etc. And then again, when those goods either come on our stock or we produce them as a manufacturing organization, right? We can go in two steps here. We obviously have to make a decision how we are going to distribute this initial allocation across our stores, right? Which stores should have better sales of pink chair and which not. And then this was so-called, let's call it a goods pre-arrival, so-called planning phase. And then in a goods post-arrival or so-called execution phase, we have also various other challenges, where we could get some support from machine learning solution. First one is being replenished from central warehouse. So, do we have to replenish our pink chair? Is the sales going good? How much should we replenish in future? Second thing, for example, really popular in the fashion industry is store transfers. So basically, when we're done, when we're, let's say, out of stock or where this season is over, we still have to answer the question, are there, for example, pink shoes in this case, left in one store and transfer them to the other store where they could be, sold more easily. And then in the end, there's a question of markdown execution, right? So if the sales is not going well, can we, lower the discount, lower the price, introduce the discount in order to sell it more easily, etc. And as you can hopefully see by this lighter pink color, I mapped also two phases, which are, let's say, strictly focused to a manufacturing organization. So first of all, ordering goods in a manufacturing organization actually means ordering raw materials or planning how to produce semi-products in order to meet, financial plans of selling the final product. And there's also another component, which we got an amazing feedback from the market. So let's say that this whole plan is already on a paper and it's executed, and what we have is actually a list of work orders. So how are we going to produce these pink chairs, right? But there's still a component that we can optimize here, and that's the schedule and the sequence of those work orders, right? In order to maximize the output in a given time frame. And this is a topic where we really have an amazing results up until now from a market. Now, when we have run through these, main managing inventory challenges, we're going to try to answer, or we are going to answer the question, how are we solving it, at Biterna? So obviously it all starts with the first module of data input. So core of our solution obviously is data input. Now, the thing that differs, ERP processes or statistical forecasts, etc., to machine learning, one of the things, of course, is integrating also third-party data. So on top of your historical sales, historical stock out, historical production, historical purchase data, what we integrate is also historical and future weather forecasts, holiday seasons, global shipment trackings, telco data if available, in-store heat maps data if available, etc., etc. And then the first module, so the core, the basis of this whole process is utilizing demand forecasting algorithms. Now, please bear in mind, this has more or less nothing to do with your financial plans that you want to achieve, right? So these are the algorithms that are forecasting the demand from a market. So based on a sellout data, so to say. Then when we have these forecasts, which inherently have seasonality analytics in it. So if your sales data or consumption data has, anything remotely to seasonality patterns, these algorithms will understand it and forecast it accordingly. And then when we have this information, the next thing we do is we recommend orders, either orders to our vendors, or we recommend, orders, quantities that we need to produce in a manufacturing organization. Module of multi-location planning obviously means that we don't do this for one central warehouse or one retail store, but for multiple, right? And bill of materials roll down means that we also integrate bill of materials information from our ERP. And when we know the demand from a market for a final product, we can easily roll down this information to understand the needs and the capacity for the raw materials and assembly products, right? And then put them in optimizing production module. Before coming to that, a few more really important modules. So cargo optimization, placing an order, either we're ordering a truck or a container across the seas, right? That volume can be optimized. Now, in order to not keep the container half full or half empty, we pull this data through the cargo optimization modules, and then try to optimize the filling of this container in order to reduce the transportation cost. Then when this order is placed, right, what we are expecting is, let's say, expected lead time of this delivery. But those expected lead times are usually just there on a paper. Okay, so what we do is we integrate with the global shipment tracking APIs. So if you have an ID or of your shipment, we can basically understand when this shipment is going to arrive to your warehouse, and then plan accordingly. Either order goods from a different vendor, or replan accordingly or something like that. As already mentioned, in the fashion retail, store transfers is something which is super important. So we also have algorithms that recognize, if the sales of an item is going better in one store or worse in the other store, and then suggest the transfers between them. And then in the end, we come up to a promotion planning. So this is really, really important component where we feed the system with historical promotional data, so the system can understand what was the success of this historical promotions. And then we also feed the system with upcoming, so future promotional data, and this recommendation system is going to take these assumptions and recommend us a quantity to order accordingly. And the last module, actually second to last module, is module of KPIs and reporting. Now, introducing solution like this is obviously also a change management issue. So what it happens in real life is that you tell to a person who's been doing this for, I don't know, 5 or 10 years, using Excel or whatever way. Now you're telling that person, hey, there's a system which, can do it somehow better. which is just partially true, because we cannot do it better without the help of a person who has the domain knowledge. And in order to bridge this gap, what we do is we deliver them KPIs and reporting in the form of, self-service dashboard in Power BI or ClickSense or Tableau or whatever you're using. And the purpose of this is to give more confidence to a person doing the purchase. So that means that, when this person takes a look at the dashboard, he or she can understand the historical sales, the forecast, simulation of a stock level, upcoming 6 or 7 or recommended orders, right? So it can give this person much more confidence to accept the recommendation from a system. And the last one that I already mentioned is, optimizing this sequence of a production in manufacturing organizations. So once when we come up to a level of work order, we can also optimize these work orders, taking various constraints into consideration. Capacity, labor capacity, nominal needs, nominal work time needed, actual work time needed, time needed for an item to switch between the lines, time needed to switch a format on the same line, etc., etc. So we put all of these information into one box and provide you with an optimum sequence of the work orders. Now, when we put this overview into something that we call data pipeline, so moving from left to right, I'm sure you more or less understand that it all starts with data input. Then, we deliver forecast, propose recommended quantities, and then integrate. So what I want to do here is actually just focus on 2 bullets that I didn't mention previously. So first one is, on top of the whole system, which is live and up and running constantly, we have something that we call Stock Monitor. So that means that you don't have to manually track if there's a risk of going out of stock, or if there's a risk of getting overstock. There's a constant Stock Monitor which detects and quantifies, alerts you, detects overstocks, stockouts, calculating missing revenue potential if we don't manage to produce something by the time, detects outliers if some sales was an outlier or standard sales, etc., and then gives you a proposal to order goods earlier or do something else, right? So this is the first thing that I want to point out. The second thing that I wanted to point out is the output. And now we're slowly coming to the, I like to call these, market differentiators, and I think it's important for us to discuss those. So first one, starting from the right-hand side, is, and it's really correlated to this output. So what we're discussing here today, that's not another system to maintain, right? We don't give you a management console. You don't have to input the expected service level. You don't have to input the promotional data in there if you already have it, So what we do, you can imagine it at this phase as a large, black box, which delivers you, we call it intelligence as a service. So that means that there are just 2 integration points of this system. First one is direct, let's say overnight integration with your ERP, okay, using APIs. You're going to see it in the next slides. And second one is the integration to a self-service BI application. So that means, understanding sales forecast, open orders, term contracts, stock simulations, etc. Okay. Second benefit that I wanted to discuss is we really cover process end to end. So that means that we don't leave this last mile of optimizing cargo in a truck alone. We also take this logistical data, pallets, trucks, volumes, pieces, etc., and we provide you with the most optimum feeling of a truck or a shipment. We use BI for explanatory. That means that this front end is not some rigid table or a simple line. It's really global leaders in terms of business intelligence and analytics, which really allows this user, to understand this recommendation and accept it more easily. And the last thing, which I also think is really important, we leave the data where it is, right? So we just integrate the data. If it's sales data, it should be in your transaction system. If it's logistical, then the same thing. If it's promotion, same thing. If it's global weather, we take it from the API. We don't ask you to provide it. So we really try to leverage all the existing data without actually asking you to input something new in it. And now this same pipeline, how I call it. When we paint the same picture from perspective of manufacturing organization, it's pretty similar. There's just another additional component called production optimization, and this is the one that I mentioned, and that is, just scheduling the work orders per each line in order to maximize the output in a given time frame, and then again back integration of these work orders into an ERP in order to actually trigger production from a process perspective, right? What ERP is used for. Okay. So what we did up until now, we went through the let's say module overview of the solution, and now what we're going to do in the next few steps is we're going to see how the solution looks from an end user perspective. I mentioned here that it's not another system to maintain. We don't have a management console. So fair question would be, okay, how does it look like? How does the user even use this solution, right? So here is how it looks like. What we have on here is the use case of purchaser starting the order process, and for this example, we're using 365 Business Central. Just for an example, right? So let's say a person comes to work in the morning and opens the requisition worksheet, enters the vendor that he or she is responsible for. She in this example, so selects vendor and sees the recommended quantities that came by overnight integration to a system. Okay, so she can revise recommended quantities. And let's say that she's concerned over this suggestion of 0 pieces for a mango order. So the next thing she can do is open a self-service Power BI app and have an insight into this forecast and historical sales. So basically, item by item, she can understand what was the historical sales, how does the forecasted sales look like. She can also understand what was the historical stock level and how does the forecasted stock level look like. So this means if a forecast happens as we assumed, and if you order goods as we suggested, this is the stock simulation in a future. And item by item, she can also understand some key information, so the name, recommended quantity, forecast, etc. Just feel more confident into ordering 0 or changing the quantity. One interesting point that I would like to show here is you see this color code here. So what this actually means, if item is green coded, that means that actually person can have confidence and that our forecast is precise, accurate, so to say. If there's a yellow or a red mark here, that means that person should double check the recommendation because, either we don't have enough information or it's a first filling or it's a slow moving item or something like that. Just to mention, this ratio here with our customers who are already in production goes up until 95, 97% on some categories of the items that they just, accept the recommendation and place the order. And now let's say she decides to change the 0 to 174, okay, and confirm the quantity to order and just place this order the same way as the order would have been placed using just a BC, standard functionality. So it's just that the information given in there was much more precise, and as a result of a pretty complex machine learning algorithm running in behind. And this is the process, how it looks like end to end. The last components that are left here is, then actually just tracking the actual sales comparing to what we ordered. Goods arrive at some point, and then somewhere down the road, there's a similar process that's going to be triggered, either another order from a vendor, either replenishment from a central warehouse, either store transfer, either production order, right? If it's a fashion organization, then maybe initial allocation, etc. So all of these processes, depending on a use case that we're solving from this first, you remember it, flow of goods, right? Challenges. So depending on which point are we solving there, we can trigger different processes integrated at different points in ERP, but more or less the process is going to look pretty similar to what we saw now. So really simple. And now this is now just zoomed up screen from a BC requisition worksheet that you see that it's completely standard functionality. We just integrated information to be much more precise, and then the links to something similar like this, where you can really see forecast simulation, all the master data information, drill, filter relatively easily, etc., etc. So basically, this is what I wanted to share with you from the product perspective. Just a final note on my side. What we showed you here now is a process, and I'm repeating it. It's not another system to maintain. So why did I even mention it? 3 to 4 times. So from our experience in the market, probably the key reason why do AI projects or machine learning projects fail? That's because they tend to change the process how a person is doing it now completely, right? We're not trying to do that. We're trying to keep the process as similar as it is and just provide the end user with a more quality information. And if you think about it in real life, the applications of AI that have, I would say, the best success in your life are the ones where you actually have no idea that it's some kind of AI running in behind, sorting emails in your Gmail, recommending songs in a Deezer or Spotify, recommending what to buy on Amazon, receiving, booking proposal from your favorite hotel chain, etc., etc. So those are all the things which are not changing your experience. And that's why we decided also not to change the experience of a person who's actually doing the purchase activity, right? And now we're slowly moving to the last 2 bullets. First one we're going to address is to calculate business benefits. And for this purpose, I prepared 2 points of view on the same problem. First one is looking from a pre-sales example. So what can we calculate already in the pre-sales activities? And the second one is from, project perspective in terms of actually sharing a case study with you, right? So from pre-sales example, please take a look to begin with on the right-hand side. So what we have here is the KPIs that we are basically able to simulate already in pre-sales phase. And typical KPIs that we, try to optimize is, for example, lower stock out situation, right? And then we try to estimate how much of a lost sales, lost revenue would this stock out situations have an impact to. Second one is less dead cash. So that means just, if you were piling up the stock in some categories, we're probably going to be able to keep it much, much lower and then keep this free cash to your CFO or your organization to invest it in some other place. And then there is, of course, decreased cost of stock handling. Here we didn't even mention some soft benefits as, lowering time that people are spending to this process, better negotiating power with your vendors, etc., etc. So why am I sharing this with you? Is just to give you an information that basically all of our projects up until now were based on pretty clear cost-benefit calculation, right? And I don't want to overpromise here, but for now, our experience was that return on investment was ranging somewhere in the area of 1 year, 10 months, year and a half, but somewhere in this area, of course, depending on how much problems with the stock do you currently have. And the second thing that I wanted to share with you is this project example. This information is coming from a pharma distribution company case study. This team is with us in production for now, I think, more than 3 years. They kick off even before this first wave of COVID lockdown. So a couple of interesting things here. So as I already mentioned, so up to 97% of the estimated future demand is correct in their case. So that means they accept the recommendations for 97% of the items in some categories. This is what they stated, that they're now spending 50% less time and a manual effort on data gathering, preparation, etc. So they just, focus on actually placing the right order. And this is pretty amazing. So, although we managed to lower their stock on some categories 25 to 65%, okay, so that means lower stock. in the same time, we actually managed to reduce number of out-of-stock situations, so number of out-of-stock days. And we did it for more than 90%. So that exactly means that a pharma retailer in those cases, was not ordering their goods, but the goods from the other vendors, right? And now this situation is solved. And twice as faster inventory turnover, but I don't want to drill too deep into this one. So let's focus on these KPIs here that we mentioned them for now. So this is from the business benefits perspective. And the last thing that I wanted to share with you to leave enough room for hopefully discussion is, how to start. Now, obviously, there is a really a simple question which should validate, like, do you even have stock issues? And that's not if you already have an ERP, if you already have BI solution, if you already have a planning solution. That's really not important. What's important is, are you experiencing stock issues in your real life? So are you experiencing stock out situations? Are you experiencing overstock situations? Are there, I don't know, 5 or 10 people involved in this purchase process? Is it too much manual effort behind it? And if the answer is yes to any of these 3 to 4 questions, then there's probably room for the improvement. And the question is how to start. So there are basically 2, action points that we usually engage with our customers. First one is, we like to call it one-day POC, and that's a free activity. So what's behind it is, that we ask you that you deliver, historical sales data and purchase data for, let's say, 20 items, and we just deliver a forecast for those items. Now, this activity is free for you. And the reason why it's free is because, it's relatively hard to validate those results. We can, take a look at the forecast, wait for the future to happen, and then validate it, right? So that's why we usually do something else. And that is not a proof of concept, but what we like to call proof of value, or in the other words, feasibility study or benefit analysis or whatever. And this use case looks in a way that we ask you for the data on 300, 400 or 500 items, right, for the last 2 years. And then what we do, we train our models on the first year and a half, and then do the simulation on, let's say, last 6 months. And then what we can do is actually do the comparison, in those 6 months. How did the actual cash outflow look like? How would it look like in our simulation? How did the stock out look like in real life? How would it look like in our simulation, And in general, what was the stock level, and how would this stock level look like in our simulation? So basically what we do after this exercise is you have, really, really precise potential financial impact, which is as close as possible to, tomorrow's data and to what's actually waiting for you in a market, right? This is obviously paid activity because there's a lot of added value behind it. And basically, if financials after this exercise say you have return on investment in 9, 10, 12 or 16 months, then customers more or less feel confident into engaging into a process like this. So basically, I think I would I put all of this in roughly 30 minutes, which was my plan, and I would stop here. Now we move on to Q&A section, since I'm still in a full screen mode. Jesper, I would kindly ask you to let me know if we have any questions in a Q&A section that I should address.
Yeah, thank you very much for this great introduction, Milan. We have some questions here. The first one, I suppose this considers lead time and or price agreements for vendor selection when suggesting planned purchase orders.
Absolutely. So yeah, I must have forgotten something, in these 30 minutes. So basically, what I didn't mention is, these forecasting algorithms and these recommendations take into account many constraints, that are available, starting from, actual lead time, expected lead time, warehouse manipulation time, annual bonuses, for example, if you need to boost sales, promotional information, as I mentioned, holiday days, etc. So basically all of the constraints which can be either obvious or something which is, domain specific, which differentiates you in the market. We integrate all of those constraints, so you can think of it as a box where we just pull in all of the constraints and get the best recommendation output out there. So absolutely, yes.
Thank you, Milan. We have another question. We have an older version of Navision. And I guess this question applies for all older ERP versions. So the question is, can we use this solution for an older ERP version?
So absolutely. I mean, the core of this solution is, something that we deploy either on your server on-prem, or ideally in Azure Cloud or in Amazon Cloud or whatever, wherever on-prem on your service. And then, as I mentioned, we just integrate two components. We integrate this information to Power BI, and we integrate your this information to your ERP, and all until we can integrate somehow either via APIs or putting this data into SQL database, which is behind ERP, we are good to go. And we had either projects or POCs with NAV, BC, FNO, AX, SAP, some local ERP systems, etc., etc. So it's really not dependent on the ERP you have. We use your ERP to get the data from there and to get the data back in there. Obviously, those are two technical challenges, but that's not something that we don't manage to solve.
Okay, thank you. Can this also be used to forecast the need of workforce as well? So resources in a production plan?
Yeah. So that's a good one also. Absolutely, yes. So basically, you can think of it is this way. Any sequence of information, that we have on your timeline. This can be shifts by the day, workforce by the day. It can be forecasted. So when we are delivering this work order schedule, it's integrating, again, many constraints, and one of those constraints, again, being workforce plan or the nominal workforce which is available. Second example is we did a project within retail section of gas stations here in Adriatic region, and they had a challenge with a large waste of fresh goods. So, for example, orange juices, croissants, sandwiches, etc. And what we did, we integrated sales data, we integrated traffic data, and we gave them forecast two things. First one is, recommended quantities to order or produce, number of sandwiches, juices, etc. And the second one is suggestion of a workforce by shifts, so they could also optimize that number. So the answer is yes.
All right, thank you, Milan. Another question here. We have multiple stores in our brand. Can this be used to propose items per store and assortment? So basically, what type of products we will have per store?
Yeah. So similar slide as I've showed you in the beginning, we have this similar slide, sorry, for the let's say fashion industry, right? For example, and if we engage in the discussion with you, we are probably going to come up with a similar slide, which is a bit tailor-made for your industry. And for example, in fashion industry, I mean, it doesn't have to be fashion industry, but I'm just taking it as an example. So we do also that, right? We plan the assortment. That means a split by categories, which should accumulate to a full financial amount. And then we plan full amount, number of SKUs we need to order. And then, for example, in the fashion industry, this is one of key challenges, maybe in different retail stores also, and that's the initial allocation, So from the first annual planning up until the execution of, initial allocation of the goods by store, it can be 2 to 9 months, and a lot of things can change on the market. So deciding on a split of those goods, this is something that we also do, and you can think of it in the same way that I showed you. So the end result you would get is the recommendation for the allocation, right? We utilize also similar items detection in there, image recognition. So there are quite a few techniques that we do in order to, forecast the sales of the item which is new and which, does not have any historical sales already there.
Thank you, Milan. And another question anonymously here. So when it comes to external databases that could influence the AI prediction of, for instance, the stock level or other things, is there a limitation to external data sources that could influence these calculations?
So there's absolutely no limitations in terms of, how much and which data can we take, but it's the question if the data is going to be significant or not, right? Luckily, we do not have to decide that. We can pull this data in, and then the algorithms itself are going to, let's say, tell us if some external data is relevant enough to use it for the future forecasting. Just an example, we did a POC with a large bank, and they wanted to predict, which customers are going to repay their credits earlier. For the bank, that obviously means a lost interest, right? So what we did in this POC, we put in there roughly 60, so 60, various macroeconomical KPIs, and then we run the simulations and forecasted in the same way that I mentioned, train the model, assess the model. And we understood that there are basically 5 or 6 that have some kind of a significant correlation with it, and the rest of them don't. And then we said, okay, we're going to focus on these 5 and utilize them down the road, on our forecast.
Okay, thank you very much, Milan. I think that's the questions that we have received up till now.
Well, if that's the case, then I would thank you all a lot from my side, and give a closing words and closing remarks, Jesper, to you.
Yeah, thank you so much for this great introduction, Milan. I just added here our contact details. You are here on the left-hand side, Milan, with your email and your there's a QR code for your LinkedIn. So feel free to connect. We have Roland Evers, that's responsible for the Netherlands. We have Patrick Janskol, responsible for Sweden. With us, we also have Fredrik Stenlund, head of customer success in Betoner Nordics, and also me here, head of sales of Denmark and Norway. So please feel free to reach out and engage with us in discussing what you could benefit from these solutions. One final note, thank you so much for joining. We already have the next webinar planned. It will take place on November 9th, and it's a similar topic about how we could use IT to create a better day at work. So this topic is around robotic process automation, how robots can help us automate our workflows. So by that closing remark, thank you all for joining, and have a great day. Thank you so much.